Alright, let us continue with this third part in chapter 6. Yeah? As I said, there are many ways of solving the same problem. This is another way, third way. What we do is we take the first cash flow at the end of, at the beginning of year 1, 500. Okay, we compound this for 1 year at 9%. So this will bring it to the value at the end of year 1. And then you add with the cash flow at the end of year 1, which is 600. Now this will be the total value of the cash flow, two cash flows, but the value of the cash flow at the end of year 1. Then you compound this cash flow, okay, the value of this cash flow, two cash flows here at the end of year 1, 4 more years to bring it to the 5th year. So you multiply this you can consider as one single sum. Okay, you multiply with 1 plus r, the interest rate, and then you compound this, raised to the power of 4. So you compound this for 4 years, so you get the same answer as well, 16.26, the same answer as here. So there are many ways of actually doing this. Alright, so we have seen that this same problem can be solved in different ways. So you can compound each cash flow separately, like what we did here, the first way, to the end of the term. So this is the 5th year cash flow. This is also the 5th year cash flow. That means the value of this cash flow is at the end of year 5. This is also the value of the cash flow at the end of year 5. Then you can add them. So this is the first way. The second way is you can sum the future values of the individual cash flows at a given time. So here you sum this. You take the single sum and then you compound this. Then you compound. So this is at the end of year 2. Okay, and then you compound for 3 more years, you get the same answer. Or you can you can sum at the end of year 1, at the end of year 1, and then you compound for 4 more years. Okay, any way, any which way you use, okay, as long as you're consistent, okay, you get the same answer. Consistent here means consistent in terms of the concept. Concept is correct here. All 3 ways are correct concepts. Is that okay? Alright, let's move on to the next slide. Okay, this is another example, so I'm going to skip that. That's not so important. This is another example. Now here we move on to another example. Here it's different because we are looking at the present value. Previously we were looking at future value of multiple cash flows. In this example, we are going to look at present value. Alright, let's look at this example. You are offered an investment that will pay you 200 in 1 year. That means in year 1. 400 the next year, then 600 the following year, and 800. Notice 200 year 1, 400 year 2, 600 year 3, 800 year 4. So this is multiple cash flow. Multiple cash flow. You can earn 12% interest. This is the second element, okay, in this time value problem, time value of money problem. 12% is the interest rate on a similar investment. What is the most you should pay for this one? So the question is, what is the present value? How much would you be willing to pay for this? We're going to get 200 at the end of the first year, 400 at the end of the second year, 600 at the end of the third year, and 800 at the end of the 4th year. Okay, how much are you willing to pay now for this cash flow? This stream of cash flows. Okay, how much are you willing to pay? So this is actually a present value problem. It means that what are these cash flows worth now? At 12%. So put it another way. So if you have a cash flow now, okay, the amount now, okay, at this interest rate, you can invest that amount at this interest rate. Can you get 200 at the end of year 1, 400 at the end of year 2, 600 at the end of year 3, and 800 at the end of year 4? Okay, and with that you finish your savings here. So how do you get the present value? Just like we did in the previous chapter. We treat each cash flow here as individual, separate cash flows. we find the present value for each at a particular time. That means time 0, present value. We find the present value of 200, present value of 400, present value of 600, and present value of 800, and then you add them up. Okay, so that's the easiest method, the basic method. So to find the present value of each cash flows, and then you add them. So we follow the first method. Just now we looked at future value. What did we do? We find the future value of each cash flows, and then you added them. So we are following that here as well. So 200 you divide by 1 plus 12%. You get this value 178.57. Then you discount the second year cash flow, 400 divided by 1 plus 12% raised to the power of 2. So you discount this cash flow over 2 years. This one you discount over 1 year, only 1 year. This one you discount over 3 years, at 12%. This one you discount over 4 years, So once you've discounted all these are all cash flows. The value of these cash flows are at time 0. Now, these are present value. Because these are all present value, you can add them. You cannot add 200, 400, 600, 800 because these are all at different time values. So, but this you can add because they are all of the same time value. Alright, so therefore you get 1432.93. Note that this is actually present value of multiple cash flows compared to previously. In previous chapter, we looked at the present value of a single cash flow. Here we have multiple cash flows. Okay, that's the difference between this chapter here, chapter 6 and chapter 5. Now we can show this in spreadsheet. We can also show this in financial calculator. Let's show this in spreadsheet first. Alright, so we look at this example here. We see the same example in a spreadsheet. Note this, here I have created a table. Okay, so you have year 0, 1, 2, 3, 4. The first year 200, 400, second year 600 in the third year, and 800 in the fourth year. So here I say it is withdrawn. That means you are able to withdraw this amount each year. Right? Now this is the balance that we've got, and this balance is actually the present value that we got from the slides just now when we did the calculation. We added the present value of all those cash flows, we got this value. So I'm going to demonstrate this. What does this mean? It means that if you have this balance now and you withdraw 200, 400, 600 and 800, at the end of the year, the fourth year, you will have 0 balance in the account. Okay, let's go through this. So this will help you understand what we mean by present value of these cash flows. So if this is indeed 0 at the end, so this 200 that you withdraw in the first year, 400 that you withdraw in the second year, 600 that you withdraw in the third year, and 800 that you withdraw in the fourth year must be equal to the balance that you have now in the account. Okay, that is why at the end of the 4-year term, the balance becomes 0. Let's see how this becomes 0. Now note this answer here and the answer that you got in the slides is exactly the same. 1432.93. I've used the exact number here. If you look at this number, it's not only rounded to 2 decimal points. I've taken the full number here. Okay. Now, how do you get this? So if you have this amount of balance at the beginning at time 0 now, okay, you will earn interest. Remember the interest is 12%. So 12% from the balance you will earn. So you will earn 171.95. That is 12% from this balance. So because this balance was available for 1 year, at the end of 1 year, you will earn interest of $171.95. Okay, but you also withdraw 200 at the end of first year. Therefore, this minus this plus this, you get this value. Is that okay? D9, note this, D9 minus B10 plus C10, you get this value. Note that the value becomes smaller. Okay, this is 1432.93, this is 1404.88. Alright, then the next year what happens is that you earn another 12% from this balance, because this balance is available for 1 year. Yeah, therefore you earn interest of 12% from this here at the end of the second year. Yeah, so you get 168.59. That is 12% multiplied by 1404.88. So you get this value. Yeah, so but at the end of year 2 you withdraw 400. So you have this minus this plus this. You get this value. Okay, so it becomes even lower. So the idea is you withdraw some amount, you get some interest, but the interest amount becomes lower because your balance becomes lower. Until the end, you get 0. Yeah. Notice the third year, you have 12% from the reduced balance, 173.47. 12% from this, you get 140.82. Okay, you add that to this balance here, but you also minus this because you withdraw 600. Yeah, so your balance becomes lower. This minus this plus this, you get 714.29. Finally, last year, the final year, you earn 12% interest from 714.29, you get 85.71, but you also withdraw 800. Yeah, so this minus this plus this, you get exactly 0. That means all that you withdraw here, 200, 400, 600, 800, is worth exactly what you have now. Okay, that is what it means by present value. Yeah, therefore, this stream of cash flows here is actually worth this much now. Is that okay? So that is the meaning of present value. I hope that is very clear. Yeah, let's go back to the slides now. Now we come back to this slide. Yeah, now I want to show you the same example. Note that, yeah, that the amount is the same. Yeah, 1432.93. Yeah, now I want to show this example in a financial calculator application. You can actually use a financial calculator, but I'm going to show you how this can be done in a financial calculator application. Yeah, this is web-based. Yeah, you can do it on the web, or you can download this financial calculator application on your phone. Yeah, and you can also use that. Okay, the problem with financial calculator on your phone is that you would not be able to use the phone during exams, final exams. But you can use to check your answer. Okay, all right. For regular calculation, you don't need to use financial calculator. Okay, you just need to show your calculation using a normal calculator. Scientific calculator will do. Yeah? Okay, but I think this is quite useful, especially finance students. Those who are doing finance program should know how to use this financial calculator or the financial calculator application. Yeah, and we will see that. All right. Yeah, so this is the financial calculator application. So the URL is stated here. Yeah, you can see it here. You can go there and get this application. Yeah. All right. Now, if you go to this, yeah, you will normally come to this page here, time value of money calculator. Okay, this is the basic page. Yeah? The first page will be this financial calculators. You go to this URL. Yeah, you get this TVM calculator. But to solve this particular problem, we have to go to Irr Npv Calculator. Yeah? Click on this. Yeah? So you'll have this window here. So the discount rate, yeah, is the interest rate. You put 12. This is already in percentage. Yeah? So don't change that percentage. So first year is 200. Okay, cash flow. Second year is 400. Third year is 600. And the fourth year is 800. Okay. And then what you do is you just click on calculate. Okay. Right. You will not be able to see this here. Let me just drag this below. Yeah. So you can see it. Okay. Now you get this value. Yeah. Net present value is 1432.93. Yeah. Net present value is actually present value. Yeah. There's no negative cash flow here. Okay, note that you should not put this at time 0, yeah, cash flow at time 0, because that will be now. Yeah, there's no cash flow at time 0. These are all here, so you get this answer. This is how you use the financial calculator application. Yeah. Right, that's all we have time for in this clip. We'll continue in